Welcome back to another video of RoboCNC. I'm Marcel and this is my new fiber laser. Alright, before we actually dive into using this thing, I want to take one step back and explain why I went with this specific fiber laser. This is an OMG-X 60W MOPA fiber laser from OMG-Lasers.com. And I've been looking into fiber lasers for a while now. And if you've been looking into fiber lasers for a while, you probably noticed something. There are a lot of brands, but not nearly as much factories actually building machines. Some brands have amazing marketing, beautiful websites and dozens of influencers. And while that's fine, in the end of the day, the laser is just a tool. And what really counts is the fiber source that's inside here, the scanning head, the electronics and the support you get when something doesn't work as it's supposed to. Along with the machine came this 80mm rotary attachment, some work stops, a little bit of tools, Richard Zhang's card, some business cards to try out, safety glasses, foot switch and 2 extra lenses with different focal lengths. So let's take a closer look at what's actually inside. This machine uses a split design. In this enclosure you will find the main power supply, the JPT MOPA fiber source, the control electronics, the key switch, the emergency stop, control of the red dot laser and probably more. When you open it up, the first thing you notice is that it isn't just a thin sheet metal box. Parts of the housing are actually machined from billet aluminum, which gives it a lot more rigidity and probably helps with heat management. At the heart of the system is the fiber source itself. The machine uses a JPT source, the YD-FLP E60M-R M7 MOPA source. The E in this part number indicates it's the economic M7, which makes this machine more affordable at the cost of lower maximum pulse energy compared to the full M7 sources. It would have been better if it was the full M7 source, but the EM7 already puts it above the more basic fiber sources such as the E2 M7 or the non-MOPA alternatives. Control-wise, everything is built around the BJJCZ LMC version 4 fiber control board, and this is widely used platform in professional fiber lasers, mainly because it's stable, well supported and it works seamlessly with software like EasyCAD and LightBurn. For the rotary axis there's a dedicated lead shine DM542J stepper driver. Lead shine is a well-known name in the motion control and these drivers are commonly used in CNC machines where reliability matters. Overall, the internal layout is clean, well organized, wiring is tidy, connectors look properly strain relieved, nothing feels like it was added as an afterthought. Now moving on to the scan head, often called the galvo, because it houses 2 galvanometer motors. These drive the silicon mirrors to precisely steer the beam in X and Y direction. The specific unit is the SuperScan SS10DA. It features a lag time or a tracking error of just 150 microseconds, which keep your corners sharp. It also has an accuracy of within 22 microrads, meaning the beam hits the same spot every time with an incredible consistency. Now this is where things get fuzzy. Laser manufacturers love to throw out big numbers. You'll often see marking speeds even exceeding 50 meters per second on the website. In reality, that's most likely the top speed the mirrors can wiggle and not what they should do for a good engraving. The truth is, your speed depends on your setup. Your lens size and even the pulse length can limit the marking speed. If you are line engraving a tiny 1mm text with a 70mm lens, you might be capped at 2 meters per second to keep it legible. But if you hatch fill a square with the same setup, you might be able to do 7 meters per second. And if you're using a huge 300mm lens, the beam even travels a much longer distance for that tiny movement of the mirror. In that case, you could actually fly past those official speed ratings. Now attached to the galvo head is the lens, the f-theta lens, and the OMG laser comes with 3 of them. A 70mm, a 150 and a 300mm. This number tells you about the square that you can engrave with it. So the 150, you can engrave a 150 by 150mm engraving area. Now that's not the only difference between the lenses. They all have their own focal length. So the 70mm needs to be like 190 millimeters away from your engraving surface. The 300 millimeter needs to be more than 500 millimeters away from your engraving surface. And that's why I opted for the riser. The OMG comes with this riser standard, and that rises the adjustable column about 200 millimeters. This way you can not only use the 3 different lenses, but you can also use the rotary attachment and engrave thicker materials. Now, when using the riser and the 70 millimeter lens, you cannot adjust the column low enough anymore. So you need something to rise your material. And this is not sold by OMG, but you can find it dirt cheap everywhere. It's an aluminum table for fiber lasers, and I just used the 3D printer to create some plastic columns to basically rise this table to be able to use the 70 millimeter lens and just leave the riser attached. So the last thing I want to mention why I went with OMG Lasers is I've been reading forum posts, Reddit threads, YouTube comments, searching all over the internet, and one name kept popping up, Richard Zhang. Richard Zhang is the owner of OMG Lasers, and I mean, he's not only knowledgeable about the lasers, the fact is you can even reach him, and that's for overseas companies really something different. I mean, you're gonna run into questions, run into problems eventually, and then when you can reach your supplier and ask them the question and get an answer, that's something that is really, really important to me. Now let's start the computer, install the software so we can finally use this machine. So the machine comes with a USB drive that includes EasyCAD. In fact, there are even 3 different EasyCAD versions, each pre-configured for one of the lenses. Normally this is exactly how you would run the fiber laser, but I'm not going to use EasyCAD. I already use LightBurn for my other laser systems, and LightBurn supports fiber lasers also. But even when using LightBurn, the underlying hardware configuration still comes from EasyCAD. Things like the scan head calibration, the field size, lens parameters. LightBurn can import this EasyCAD configuration, so I'm still thankful for these 3 different folders. So before starting LightBurn, let's first start with the drivers. They are on the flash drive, in the folder drivers. Let's open up the device manager by clicking the Windows key and typing device manager. I've already connected the laser to the computer and it found a USB LMC V2 with an error. Let's double click driver, say update driver, browse from the computer on the USB drive, finding the driver folder, and I go with the 64 AMD version. Next, and it seems to be okay now. So now the next thing we do is go to the LightBurn folder. See program files, LightBurn, and then we see an EasyCAD 2 driver. Install this one. All done. Now let's open up LightBurn. In the bottom right you see devices, and if you have installed both of these drivers you can do find my laser. Push next. It finds a JPT fiber, click add device, and now you can say import EasyCAD config. Let's click that, go to the flash drive again, let's click the first lens, 7070, EasyCAD, and then plug, and then find the config7 file and click open. Now you see it imports all the settings for this specific lens and machine. Click next. I will call this the OMG-X 60W MOPA 70mm and click next and finish. So now we have the OMG 60W 70mm lens and so on for the different lenses. So now on the right we can see we have the 3 different lenses and all the machine setup installed in LightBurn. Last thing I want to do is check the alignment of the laser. So what I'm gonna do is select the 300mm machine profile, install the 300mm lens, power up the machine, and for alignment I'm gonna draw a big square and click frame. Now the red dot will show the outline of this square, which I then use to align the laser head to the fixturing table. So it's finally engraving time. Let's start with some steel out of the OMG box, the rotary chuck key. And that's fast. And it looks super clean. Now something much softer, a plastic. This is 3D printed PETG. And again, this also comes out really clean. It's a bit whitish engraving. Now maybe my most favorite material of all on the fiber laser, and that's brass. Now this is engraved using two different settings, and therefore you get two different colors. And I will do more in-depth videos on this topic, but man, I love it. These are black anodized business cards, and in the first one you saw me engrave, well, basically normal engraving if you want to do like a business card or something. But now the second one, this one is really special. Really small dots engraving, and well, just wait for it. Well, I can tell you that the machine can do much more materials than you've seen today, and I'm gonna do much more videos, so make sure you subscribe to the YouTube channel of RoboCNC. I hope you liked the video. If so, thumbs up. If you're not already subscribed, make sure to hit the subscribe button, and I hope to see you in the next video. Thanks for watching.